Hello and welcome back to Gaffy's Grinds. This is video 2 in our series on energy for junior cycle science. You should have watched video 1 first, otherwise this is not going to make much sense. So if you haven't done that, go and do that now. The usual reminders for watching these videos, you need to try and eliminate any distractions by closing down any open tabs or social media that you have open. And also, I'm going to be giving you things to do. It's really important that when I ask you to do a task or when I ask you to do questions that you do them, otherwise you're not going to learn very much. And I know that you're all here because you want to learn. So try your best to do the questions the way I ask you to. Right, in our previous video, we learned about something called energy stores, and we learned that there were 8 energy stores, but we discussed 5 in detail. What I want you to do now is speak in your answer to the screen. I want you to tell me what are the 5 energy stores. So speak them out now, the 5 energy stores that we did in detail. So take your time, speak them out loud now to the screen. Okay. These are the ones you should have said. We should have said the thermal energy store, kinetic energy store, and gravitational energy store. So well done if you got those 3. And there were 2 more. We had the elastic energy store and the chemical energy store. Excellent. Well done if you got those 5 right. If you got those 5 right, you're doing really well. For bonus, can you remember the other 3? So by speaking your answer to the screen, do that now. 1, 2, 3. Okay, hopefully you mentioned things like the magnetic energy store, the nuclear energy store, and the electrostatic energy store. Now, I don't want you to worry too much about those 3 if you found that difficult to remember them. If you remember the other 5, then I'm pretty happy. Right, we're going to begin today's video. We're going to look at something called energy transfers. But we're going to begin, like I usually like to, with an example. So here, I want to imagine that we have a person, and they're in school, and they're pretty sad because it's cold. Winter's day, it's like today, it's like 3 degrees outside, and they're really, really cold. Their temperature is too low. This is why they feel cold. Their temperature of their body is too low. We say that there is not enough energy in their thermal energy store. So to solve the problem, they get a hot water bottle. So here is a hot water bottle, and they hold it close to their body, and it warms them up. It increases their temperature, makes them warmer. And now they are a happy student, like we want everybody to be. So it warms them up and they're happy. So what has happened? Well, what has happened here is that energy has moved from the thermal store of the hot water bottle there was a lot of energy in the thermal store of the hot water bottle, and that's why it felt quite hot. And it has moved. This arrow shows the energy moving. Well, it has moved objects. It has moved to the thermal store of the person. Now, when this happens, energy moving from one object to the other, we say that an energy transfer has occurred. So when energy moves from one object to another object, we say that an energy transfer has happened. So in this case, energy was transferred from the thermal store of the water bottle to the thermal store of the person. I want you to pause the video and I want you to take this definition of an energy transfer. So do that now, please. Okay. You should only be playing the video if you're taking down the definition of an energy transfer. Now, in this energy transfer, energy from one object in the hot water bottle has increased the temperature of another object. When this happens, this type of transfer is called heating. So we say that when energy transfers from the thermal store of one object to the thermal store of another object, and or changes the temperature of the second object, we say heating has occurred. And in heating, energy always flows from the hotter object to the colder object. So it doesn't flow from the person to the hot water bottle. Definitely doesn't do that. That would be silly, unless the hot water bottle was really cold. So for some reason, someone played a trick on you and filled the hot water bottle with really icy cold water, and then it was felt really, really cold. If you picked that up and held onto it for ages, that would make you cold because energy would transfer from you to the cold water bottle. Okay, so imagine having a bottle of water that was in the freezer, just a normal bottle, so a bottle of ice. If you held that, eventually that would feel really, really cold because all the energy would be moving from you to the bottle of ice. And that's because energy always moves from hotter objects to colder objects. We call this, when energy moves from one object to another, we call it heating. So heating is a type, it's the first type of energy transfer. Take a look at another example. Here, there is a box. It's just sitting. It's been sitting for a while. It's not moving. It's a big box sitting on the ground. Now, a person comes and starts to push the box, and it moves off in this direction. Now, when the box starts to move, we say that energy has been added to the kinetic store of the box because it's moving now. So it must have energy in the kinetic store. So energy has moved to the kinetic store of the box. Now, where did the energy come from? Well, it obviously came from the person. Now, when we talk about people doing things that involve their muscles, it's easiest to talk about a person's chemical energy store. The chemical store of the person. Now, people have energy in a chemical store from the food that they eat, specifically from a substance called glucose that they've eaten in their carbohydrates like potatoes and pasta, cereals and things like that. We eat those for something called glucose, and glucose acts as our chemical store. And when we start to move our muscles and make our body do things, then energy is transferring from our chemical store to an object that we're trying to move, like the kinetic store of the box. Now, energy is transferred from one object to the other, so there is an energy transfer. Now, it's not being transferred by heating because this is not to do with, we're not talking about temperature here. The temperature of the box hasn't gone up. We've just made it move. This is called mechanical working. Again, you should just be listening. Don't try and frantically write down what I'm writing. Just listen. So mechanical working. And anytime there are physical forces, normally when they're in contact with each other, like pushing or pulling or dragging, and it doesn't just have to be a person. It could be a machine pushing on another machine. It could be a machine pulling on another machine. But anytime there is like a physical force in contact and it's making something happen, we say that energy has been transferred by mechanical working. Let's look at another one. This here is a guitar string and it's connected at two ends. So say we've just got two little pins. We've connected the guitar string and we pluck it. And the plucking, we pluck it, which makes it go up and down. We call this moving up and down of a guitar string. It moves up and down really quickly. We call this a vibration. Now, if it's vibrating, moving up and down, then that means we've added energy to the kinetic store of the string. Kinetic store of the string. So it's vibrating up and down, and I can hear it. It's making a sound. So the guitar string, I can hear somebody has plucked it. And the thing is, there's this thing in my ear called an eardrum. And when I hear a sound, it vibrates as well. So we say that energy moves from the kinetic store of the string to the kinetic store of my eardrum. Made my eardrum vibrate just like the string is. So energy has obviously moved from the kinetic store of the string to the kinetic store of my eardrum. Now, we're obviously not talking about heating because the string doesn't make my ear get hotter. And we're not talking about mechanical working because the string and my ear aren't touching each other. So there's no forces in contact. It does it by sound. And sound is a type of wave. So we call this type of transfer a wave transfer. Now, there are two types of waves that we are going to be looking at. Waves, and waves can be either light or they can be sound. We can have sound waves and we can have light waves. Now, there are other types which gets a bit more complicated. So we're just going to keep it simple and we're just going to think about two types of waves. Okay, so waves, sound is an example of a wave. Sound is an energy transfer that transfers energy from the kinetic store of a string to the kinetic store of my eardrum. So that is the third type of energy transfer, is wave transfer. So we have wave transfer, and the types of waves are light and sound. The last one is a little bit more complicated again. We have a battery. So if we take a battery, what type of, or what store is energy in a battery? You should know this from the previous topic, the previous video. So on 3, speak your answer to the screen. Okay, you should have said chemical store. So we take our battery and we connect it to a fan. So here's a really bad effort at drawing a fan. So it's like one of those handheld fans that you can hold up and cool yourself down. So we've taken the battery, we've connected it to the fan, we turn the battery on and the fan starts to spin. So the store of energy in the battery is the chemical energy store. So it's the chemical store of the battery. And energy is moving to the kinetic store of the fan because the fan is going to spin around, it's going to move. So the kinetic store of the fan. So energy is transferred from the chemical store of the battery to the kinetic store of the fan. Now, it's not mechanical working because there's no forces. Battery is not pushing or pulling the fan. It's not heating. It's not heat that's making the fan spin around. And it's not waves. It's not traveling by sound or by light. We say this type of transfer we call, so energy has moved from the chemical store to the electric or to the kinetic store of the fan, and it's moved along these wires. So these here are wires. When this happens, we call this electrical working. Electrical working is the fourth type of transfer. So we talk about 4 transfers. Let's quickly recap them. We have heating. Heating is the first transfer of energy, first type of transfer. We have mechanical working. Happens when you've got 2 objects in contact and there's a force applying. So one object applying a force on another object, causing it to move. So either a push, a pull, or a drag, something like that. We have wave transfer then, which is basically sound or light. And we have the last one. We have a power supply, and we have it connected to a device like a fan or a motor or something like that. When the energy is carried by wires, we call this electrical working. So there are 4 energy transfers. Now, before we go any further, a reminder here that from the previous lesson, you had this taken down. You had the energy stores, a little mind map, and you had 8 energy stores taken down. What I want you guys to do is I want you to do another one now for energy transfers. So I want you to pause the video and do this mind map for energy transfers. Okay, this is what you should have. So you should only be listening to my voice if you paused the video and you did this for energy transfers. So the first type is heating transfer. The first type of energy transfer is heating. The second type of energy transfer was mechanical working. And this happens when one object applies a force on another object to transfer energy to it. The third type we learned about was wave transfer. And I want you to pause the video and tell me about the 2 types of waves. Write them down. Pause the video, write down the 2 types of waves. Okay, you should have had light and sound. Well done if you got that right, light and sound. And the final type of transfer was electrical working. Now, a really important thing to note is we've got 2 separate things here. We've got energy stores and energy transfers. If a question, or if somewhere in the future you have to talk about an energy store, if a question asks you about an energy store, it can only be one of these 8 answers. It has to be one of these. And it's usually, we're not really going to be asking questions about these. So you can kind of forget about these for now. So a question, if it asks you about an energy store or a type of energy, we only be talking about these 5 energy stores. It cannot be one of these if it asks you about an energy store. If the question asks you about an energy transfer or how energy moves from one object to another, then it can only be one of these 4. It cannot be these. So you have to make sure you check your question always to figure out what they're asking you for. So always check your question. Is it about an energy store or an energy transfer? Are you ready to do some practice questions now? Okay, so we're going to begin by pausing the video in a second. It's about somebody swinging a tennis racket. You've got a person who's playing tennis and they swing their tennis racket. You have to complete the sentences. I want you to write out the full paragraph, but fill in the blanks. There's no point just writing the blank words because that doesn't help you practice your science writing. So I want you to pause the video and write the full thing, but fill in the key words. Okay, so you should only be watching if you've completed this with the key words. Okay, so at first, the person has energy in their something energy store. So they're just standing, they haven't swung the bat yet, haven't swung the racket. Where are they going to get the energy to swing the racket? What store will they be using? So think about here, it's about the energy they get from food. Okay, so if someone wanted to go play tennis, they wouldn't do this if they hadn't eaten for 3 days. They wouldn't have enough energy. So what store would the energy be in that would allow the person to move their muscles? Okay, you should have written chemical energy store. Well done if you got that right. Chemical store. So at first, the person had energy in their chemical store. When they swing their hand, they transfer energy to the rackets. Okay, now this is about a store again. So it has to be one of the 5 stores. Okay, so the rackets, what store does it have when it's getting swung, when it's moving? Okay, so when they swing, the racket is moving. So if you didn't write an answer, pause the video and write it now. Okay, it should be the kinetic store of the racket because it's moving. Good, well done if you wrote that. By the transfer, what type of transfer would cause the person's hand to make the bat move? Well, they'd be kind of pulling the racket down. So they'd be actually physically applying a force to it. So the 2 words here are mechanical working. So at this stage, check your answers. You should be either ticking them like this or you should be fixing them. The racket then hits the ball and energy is transferred to the ball's something store. So as the racket hits the ball and the ball then moves off in the other direction, what energy store would the energy have gone into in the ball? Well, it's moving or it's changing its movement. It's probably moving faster if it's just got hit with the racket. So pause the video and write the answer if you don't already have it. Okay, it's going to be the kinetic store of the ball. And how was it transferred? So the ball physically hit, the racket physically hit the ball. So this is contact, it's a force, it's a pushing force of the racket on the ball. It's going to be, again, mechanical working. Well done. If you got that right, good job. Tick them or fix them. A few more now. Got some questions to practice. Okay. So each one of these is going to be giving you a scenario. So for example, a person lifts a cup and puts it on top of a shelf. So they lift it, put it on top of a shelf. Let's do number 1 first. Don't pause the video and do them all. Just pause the video and just do number 1. See how we get on. Okay, so for number 1A, you should have had, which store does energy come from? Well, the person is using their muscles here, so it's going to be the chemical store. Which store is the energy transferred to? Okay, so it's going to be, well, you're lifting the cup and putting it up on a shelf. So that's going to be the gravitational store. Well done if you said that. And how is the energy transferred? What type of transfer is it? So again, this has to be a transfer, not a store. This will be mechanical working. So well done if you got that right. So we should have had first answer, chemical, second answer, gravitational store, and then the third answer would be mechanical working. All right, let's take number 2 and number 3 and do them now, please. Okay, so you should only watch the video if you've completed 2 and 3 here. Okay, let's go through them. A person buys an electric heater, and uses it to heat up a room. How is energy transferred to the heater? So from the plug to the heater. Okay, well, that's going to be electrical working. Okay, so to the heater. It hasn't gone from the heater to the room yet. So just plugging it into the wall. You've gone from the mains power basically to the heater. That's going to be electrical working. Well done if you got that. How is energy then transferred to the room? That's going to be heating. And which energy store receives energy from the heater? So this is a store. Well, the temperature of the room is going to go up. So we say energy has entered the thermal store of the room. Thermal store. Well done. A light bulb lights up a room. How is energy transferred to the light bulb? Well, again, the light bulb is connected to the electricity, or to this, you put your light bulb into a lamp, and that's connected to the electricity. So this is going to be electrical working. How is energy transferred to the room? How is this energy transferred to the room? It's transferred by a wave transfer, as light wave transfer. The bulb gets hotter. What store of the bulb gains energy? So the bulb's after getting hot. So the temperature's gone up. So that's going to be the thermal energy store. So take it or fix it. And someone touches the bulb and gets burned. How is the energy transferred? So someone touches the bulb and it's so hot that it transfers to their hand and burns their hand. So think about that. What would happen to the temperature of the hand? It would go up. So it's transferred by heating. It has to be heating. It's got to be one of the 4 transfers. It's heating. Okay, so now that we've done those and we've got a flavor for how to do those, here are some more. We've got questions 1 to 3 again. So pause the video and do them now. A person is jumping on a pogo stick. So a pogo stick, we saw Tigger on the pogo stick in the first video. As they push down on the stick, energy is transferred to the spring. So it squeezes the spring. Okay, so A, which store is the energy in the spring in? Okay, so the spring can stretch or compress. So which of the 5 stores would that be? And that is going to be elastic energy store. Well done if you got that right. The spring opens and pushes the person up. So it's physically pushing against them, pushing them up in the air. Which energy store becomes filled as the person is moving up? So as the person is moving up, that would be, as they start to move, the kinetic store would be filling. Okay, the kinetic store. How is energy transferred from the spring to the person? So it's the spring is pushing on the person. So this is a physical contact or force. That's going to be mechanical working. D, the person stops at a certain height. Right before they start to come back down again, which energy store is full? So they've gone up to their maximum height. So they've lifted off the ground and a store has filled up. So which store is that? That's going to be the gravitational store. Well done. And if you're really struggling with this, guys, then I suggest you go back and just recap video 1 again. If you're really struggling with these stores, if you're getting a lot of these wrong, you need to go back and watch a bit of video 1 again and look at the stores again. As the person falls, which energy store starts to empty and which energy store starts to fill? So when they're coming down, they're not as high anymore. They're not lifted up as much anymore. So the gravitational store will be emptying. And as they are falling, they will be moving faster and faster. So the kinetic store will be filling. All right, that one was quite hard. Okay, that one there is a little bit tricky, that one. Okay. Number 2, a drummer plays on the drum kit. They transfer energy to the drumsticks, which transfer energy to the drums, and then transfer energy to the room. So we've got a lot going on here. As you can see, the questions are getting a little bit more complicated each time. They transfer, so a person is playing on the drum kit, they transfer energy to the drumstick by their arm. That then transfers energy to the drums. They physically hit the drum, and then the drum transfers energy to the room. So it sends energy out as sounds to the room. Part A, which energy store, this is about a store, does the drummer transfer energy from? Well, the energy would start in the chemical store of the drummer's arm. So well done if you said that, the chemical store of the muscles in the drummer. Which energy store does the drummer transfer energy to? Okay, so they would transfer energy to the trying to think here for a second. They would hit the drum and then they would transfer energy to which store? Sorry, my video's actually just messing up here. Don't know where my screen's gone. So as the drummer swings the stick down to hit the drum, I suppose it's going to be the kinetic store of the drumstick is going to have filled up. So they've gone from the chemical store in the muscles to the kinetic store of the drumstick. So they've transferred it to the kinetic store of the drumstick. How is the energy transferred from the stick to the drum skin? So what energy transfers happening here when the stick bangs the drum? Well, that's a physical contact, a physical force, so that's going to be mechanical working. So well done if you said that. And then how is energy transferred from the drum skin to the room? Well, that's going to be by sound, and that's going to be a wave transfer, waves. Water is boiled in a kettle. Energy is transferred by electrical working to the kettle's heater, then transferred from the heater to the water and to the kettle's wall. So the water and the wall of the kettle warm up. Which store of the water gains energy? That's going to be the thermal store. So as the water warms up, energy is being transferred into its thermal store. That's what makes it get hotter. How is the energy transferred from the heater to the water and the kettle's wall? How is energy transferred from the heater to the water and the kettle's wall? So which energy transfer is this? Okay, this is going to be heating, because the temperature of the water and the temperature of the kettle's wall are going to increase. So we say heating is happening. All right, there's a lot of stuff going on in those. So number 2 and 3, they are quite difficult. So well done if you got them right. If you didn't get them right, then I suggest you go back and watch parts of the video again, find out the different stores again. Okay, now here is number 1, the last question, sorry. Look at the diagrams below. It shows a person falling from a tree onto a trampoline. So here, the boy is sitting on the tree. So he's sitting on the branch above the trampoline. He hasn't jumped yet. He's sitting there, sitting in the tree. He's lifted. He's up high. The boy then falls or jumps onto the trampoline. And when he hits the trampoline, for a very fraction of a second, he's not moving anymore. The trampoline goes down and then he stops moving. The trampoline then pushes him back up and he starts to come back up. And the boy, we say he has bounced. So he has been pushed back up into the air. He's moving again, and his height he's getting higher again as he moves up. So let's pause the video and try and do this question. Okay, so again, in part A, you're being asked what energy store is involved. So it has to be one of the 5 energy stores, not the transfers. So when the boy is sitting on the branch, he hasn't moved, he hasn't jumped. What energy store is involved? Well, he's up high, so we say he's got energy in his gravitational store. So well done, we say gravitational store. When the boy is falling, so he's moving now, he's actually falling, which energy store is emptying and which energy store is filling? So that would be the gravitational store is emptying because he's not up as high anymore. And as he's falling, he's moving faster and faster until he hits the bottom. So his kinetic store is filling. When the boy is on the trampoline, which energy store of the trampoline fills up? So as you can see, the trampoline bends downwards like this. Okay, it does this because it's got loads of springs. It doesn't snap, it bends downwards, it stretches. So we say its elastic store has gained energy. So energy has entered the elastic store of the trampoline. It has stretched. How is energy transferred from the boy to the trampoline? Now, how is energy transferred? So this has to be about one of the transfers. So check your answer that you have talked about a transfer. Okay, so from the boy to the trampoline. So the boy is pushing when he hits the trampoline, he physically pushes it. He pushes it down. So what transfer is that going to be? It's a physical contact, a push. Okay, hopefully you said mechanical working. In terms of the stores and transfers, what happens when the boy bounces back up in the air? Okay, so in terms of stores and transfers, what happens when the boy bounces back up in the air? Well, the stores, when he bounces back up in the air, the stores that start to fill up as he moves up, the gravitational store is going to fill up. Okay, so as he moves higher and higher, his gravitational store is going to fill up. His kinetic store is going to empty slowly as he moves up. So his gravitational store is going to start to fill and the kinetic store is going to start to empty. So he'll start off moving very quickly and his kinetic store will have a lot of energy. And then as he gets higher and higher, his kinetic energy store will decrease, and that's why his speed will slow down and his gravitational store will be filling up. The transfers, well, how does he end up going back up into the air? Well, the trampoline pushes him up. So transfers energy to the boy by mechanical working. This one here is quite difficult, so well done anybody who wrote an answer to this one. It's quite tough. F. Why is there no energy transfer in part B? So let's look at part B again. When the boy is falling, he's just falling, which energy store is emptying and which energy store is filling? There is no energy transfer here because the boy is falling by himself. Energy might be moving in and out of his stores, but energy is not moving from one object to another. So an energy transfer only occurs when energy moves from one object to another. So in this case, the boy is just falling. He hasn't hit anything and he's not transferring energy to anything else. So he might have one store that's filling and one store that's emptying. Energy is moving in one store and out of another, but it's not moving to another object. So we don't talk here about an energy transfer. Now that one is quite difficult, so if you didn't get that one, I'm not too concerned if you've done well on the rest. That's the end of today's video on energy transfers, a really important concept. So it's really important that you spend the time and you're getting these answers right before you move on, okay? If you haven't done well on a lot of those questions, then you need to go back and watch the video again, or some of it, when we talk about the different energy transfers and make sure we know the difference between an energy store and an energy transfer. If a question asks you about an energy store, the answer can only be one of the 5 energy stores. If the energy asks you about how energy is transferred, if the question asks you, sorry, about how energy is transferred, then the answer can only be one of the energy transfers. Okay, so that's it. It really is that simple, but and that's it. We're going to finish it up there for today. I will see you in the next video. Do give the video a like if you found it okay and easy enough to follow, and I will see you in the next video. Thanks, guys. Bye bye.